Okay, so yes, my name is John Adams from Keysight's NSS, here to give you an introduction on edge visibility and active network performance monitoring. Okay, so we'll go ahead and get started now. So before we start talking about Hawkeye, I want to give a little bit of information about Ixia, as you may have known us as, and Keysight Technologies, as we're known as now. So quickly, Ixia started out as a layer 2 through 7 testing company, and after becoming a market leader in this area, it moved into the network visibility segment by acquiring Anomaly and NetOptics. From this point, we smash technologies together and we get the Vision One network packet broker, and we lead into these other platforms such as CloudLens and Hawkeye, eventually leading us to the acquisition of Keysight. So just so you're aware, the Hawkeye platform is a re-envisionment of the same testing methodology and technology and experience that founded the company, but we had a use case for the same testing methodology in active monitoring or monitoring production networks, which would require smaller amounts of traffic just to verify the configurations on my systems during certain loads of certain days of time. So again, quickly about Keysight. Keysight actually comes from the original Hewlett-Packard in the side of the electronic test and measurement business. This side of the business had a spin-off into Agilent Technologies, of which later just this electronic and measurement business had another spin-off to Keysight Technologies, where they have a very, very strong focus on 5G testing technology, where Ixia also complements that portfolio with our ability to emulate things like the virtual evolved packet cores. So from there, we'll talk a little bit about some of the older, original, mature test equipment, and then come into the Hawkeye platform. As you see, Ixia focused on having a solution for testing every bit of the system in a pre-deployment type of setting. So again, we're doing testing for high load, high capacity, security testing for your firewalls and IPSs. But when we focus on network performance and we move into the production environment, these very, very high load devices are not what we're looking for. We're looking more for controlled amounts of traffic to be sent between specific points so that I can always verify my network configuration is still valid, or my hardware is strong enough to handle the load that I'm seeing inside my environment. So from there, we go to Hawkeye, which is a single pane of glass controller for these endpoints to allow you to have testing between branch offices, data centers, and both the private and public infrastructure cloud environments. So focusing a little bit more on the endpoints, we have the Vision Edge 1S, which is a spin-off, from the visibility packet broker, or the Vision Packet Broker portfolio, but this packet broker will be managed from the Hawkeye UI. So from that, we gain traffic statistics. We have NetStack packet broker capabilities. We have the ability to do some of the NetStack or AppStack feature sets by generating NetFlow data. We can use this as a Hawkeye endpoint, and in a lot of other situations, we can start to support third-party software and environments such as Security Onion. So from there, we can go to some of the in-user type equipment testing, such as testing Wi-Fi networks with our XR Pi. The XR Pi is a Raspberry Pi 2 that's retrofitted with this extra dongle and extra software so we can gain extra analytics. Lastly, we move over to the IxProbe, which will allow me to once again gather traffic statistics, act as a Hawkeye endpoint, and it's generally used for the more remote locations or the locations that might be missing an IT staff. And then at the very last, software endpoints. These could be applied to your container environments, to your virtual environments, to your cell phones as well. So you can find these endpoints on the Android Play Store or the Apple Store. And as you would see in the bottom left, the idea is that you would have these endpoints distributed anywhere across the globe, with the concept of managing anywhere from hundreds to thousands of these endpoints. So very quickly, just these slides will be probably made available available to you after the presentation, but so you can see some of the differences between the types of hardware and the software endpoints. As we would say with Wi-Fi monitoring, we only have the XR Pi and the software endpoints because they would have the Wi-Fi NIC cards required to make that type of transaction. With that, if you want to do things like web application monitoring, you would need to use a hardware device or the XR2000 or Docker deployments. So what is synthetic monitoring? To me, I say synthetic monitoring allows us to control the variables and reduce the algebra. Because when we're talking about active monitoring, we're talking about testing inside the environment, and we want to make the math easy. We need to make sure we can reduce this math as much as possible so we can have very clear results on what is happening. So in this, we start with node-to-node testings. So again, this can be done from specific hardwares or the deployable software. But we use endpoints to allow testing of specific types of traffic, such as voice or video traffic, between these points to verify network configuration. What this means is that I have not included the application as a possibility of adding latency or delay in the transaction that's going across that application. So again, I'm focused purely on network configuration and potentially even some of your security configurations as the traffic may pass through multiple sites. So once I've done my testing to verify my configuration is good, I'm now ready to move into a real service test. And this will now allow me to test through my good network configuration, how is my application responding? Because I can now understand latency, delay, and loss from point to point. Now I'm just adding in that next variable in my math, how is the application responding? And in thus, we can use an endpoint to context such as the Microsoft 365 suite to verify your mail services or your team services. If you want to have a team call, a voice video call, you want to verify that not only the traffic is making its way just through your environment, but all the way to the provider as well. So with this also, we can include path discovery. Path discovery is another feature set to turn an image and create, 1,000 words or 10,000 words. And the idea being that I need to be able to analyze this information fast, so we have visualizations to help you do this. So from here you see I have thicker lines and thinner lines that identify which paths are being used the most, which are not being used as much. We have colors that may be applied to these graphs so you can easily identify where I might have loss or extra latency. So, and then at the end, we come to our performance analytics. Again, we see here we have a lot of drill down graphs that focus on specific statistics on each type of test. With these past fail type values that are configurable by you, the technician, or by a machine learning process I'll talk about in a moment. But with this, with these graphs, not only is I, the technician, will be able to thoroughly understand how loss or jitter may be seen inside my environment, these same reports will be usable to bring into presentation to the management meetings to say and explain, do you not see we have a lot of loss and delay when we have bidirectional calls between our different branch offices? We perhaps want to increase our spend on our router environment just to make sure we have enough capacity and bandwidth, especially today when we have VPNs slowing down everything. So where does the machine learning part come in? The idea is that with Hawkeye, I can take a single technician or a small group of technicians and now give them 1,000 hands. And with these 1,000 hands, they can go and test in 100 different environments. But each environment will have its own little bits of differences that created different results. So therefore, we can't get a general standard of how a threshold or a fail state would be identified at across every location because there's different models, different softwares, and things of that. So as I said, first we'll conduct our node-to-node testing to verify our configuration as the best it can be for that environment, for those models, for those softwares. From there, we initiate the machine learning process. And now, while it's conducting tests, it's going to say, hey, okay, I understand that as I'm going through these types of tests in this environment, these thresholds are seen okay. And the engineer will verify that, and now you have a a machine learned threshold engine that specifically identifies what's good or bad in that environment to allow you to identify outliers. An outlier will be any statistic that will be related to the type of test that's being sent across. So for example, as we see on the right, if I'm using a voice bidirectional test, I can have jitter results coming from the voice from to, but then also below the to from. In this way, I can understand, am I only having outliers coming from a specific office, as in, is this a one-way issue, or is it something else that might be involved? So again, we're going to go into some of these use cases for synthetic monitoring. So the traditional idea as we move through networks was actually just to take everything I have and move it to the new environment. But now we're starting to see we're having a very, very hybrid multi-cloud types environments with not only self-hosted type applications, but software as a service where everything's just done under transactions across HTTP. So this Hawkeye will allow you to get a bit more dynamic and flexible in how you leg out your testing. As you'll see here, now we can have very, very, let's say, linear testing formats to test every point of my environment across every data center and branch office. I can test across multiple types of mobile devices, Android or iOS, and cross-reference that against my XR Pi to verify if certain devices are having better performances on different parts of that network. So from there, we can go into Wi-Fi testing. It's a common, let's say, I would say a common customer for this type of testing would be hotels. Hotels very much need to understand how the traffic is being conducted across these Wi-Fis across every single floor. So what you may want to do is have a couple of XR Pis that are just sitting on certain floors to ensure that we have a good control testing to verify, well, is it the actual Wi-Fi access point that's having a problem, or is it the user's equipment such as their own personal mobile devices which don't have a strong enough antenna and they're complaining for no reason? So this is how we verify this, and this is what we end up wanting to do in all the situations with Hawkeye. We want to verify the pain points before the customer can. This very much changes the customer experience when it comes to support. No, we are very much aware that the problem is there, but only if you don't have an antenna of this X capacity, or you don't have applications set to, or your certain settings in this way. From there, we'll go into the IxProbe. And down below, you can see kind of, it's like a step-by-step diagram of how you can imagine this placement would be. Again, this is going to be an inline device that's using some of our bypass technology to ensure that it will always fail in a safe manner, so it's a risk-free device. With that, we also allow you to gather statistics from this device with the use of SNMP, and now it's also used as a Hawkeye endpoint. So as you'll see on the bottom, it's traditionally going to go into, let's say, smaller business environments where like an ISP might send a modem, small like modem rack to give them their connection to the internet. In a lot of cases, the ISP was unable to understand how the customer was experiencing the service on their side because they had no equipment inside that data center, however big it was. So what we get at the end from here is that the ISP can have this installed directly from the modem leading to the client's router to allow me to understand how traffic is going from my centralized location where I'm providing internet across the internet to my modem on the other side, and then I can do active tests between these locations. So at any point the client starts to complain, well, I'm not getting good service to Microsoft 365 because I don't see X amount of speed, the ISP can verify, well, we're not seeing what you are seeing. It may be your applications or your network configuration. So in all cases, in a lot of cases, this can be very useful for SLA verification and QoS monitoring. As we'd see here, a further explanation into that point, as the provider, I would have my own provider cloud, maybe a customer network. I'd write across an internet, but once I get to their data centers, I'd cross the IxProbe first. in which I will now have SNMP monitoring, synthetic monitoring, and I can look a little bit inside their environment to ensure they are receiving the service I have agreed with them. And real quickly, you can see some of the statistics that would come along with this. So now we'll go to the Vision Edge 1S a little bit more into focus. So this is a packet broker that's focused on 1 gig with 4 10 gig SFP pluses. It has the ability to generate net flow, or more specifically, the IxProbe from Ixia. It allows you to do things like application-based filtering, so I can filter, say, on Microsoft 365 or Facebook or YouTube. And with this, we have this synthetic monitoring, meaning I can create up to 10 gigabits of traffic generation from this device, let's say for not the so remote, but still edge type environments. The deployment topology would generally follow as such. I would use a Vision Edge 1S to do some type of pre-filtering, of which I would send this traffic to a Vision 1, which is part of a larger centralized data center where I would have a very, very large tool farm and perhaps like an auditing type device to record all the transactions that are happening at each of my locations. On the other side, if we have a situation of bandwidth where the idea of sending the entire packet might be too much. In a lot of cases, there's a play to try and use packet slices or packet slicing or packet trimming. Another way to do this quite easily is to use NetFlow or our IxFlow, where you're going to be able to reduce that traffic down to about 3% of its size, to which you can then pass it across your very, very expensive pipes to your NetFlow collectors at the distant end. Okay, I want to thank everybody for their time now.